Okay, 27. A life insurance company sells a $250,000 1-year life insurance policy for $200. The probability she survives is 0.999544. Compute and interpret the expected value of this policy to the insurance company. Okay, so if we make a model here, or a table, a distribution, the the cost to the insurance company, that's going to be what X is, because that's what it asked for. What's the expected value of the policy to the insurance company? That's the key to knowing what numbers go up here. Well, if she lives, the insurance company is going to make plus $200. If she dies, they're going to lose $249,800. They're going to pay out $250,000, but they already collected the $200, so they're really paying out that much. And the probability of each one happening are these, right? They told us this value. This is just 1 minus it. So the expected value will be 200 times 0.999544 plus negative 249,800 times 0.000456, and that's going to be $86 if you do that. And so what does that mean? That means in the long run, or on average, over thousands of these policies, the insurance company will make approximately $86 per person. Now remember, that's an average number. They're not making $86 on anybody, but on average, after hundreds and thousands of these policies, that's what it's going to end up averaging out. Because some they're going to pay, most they're going to collect $200 on, some they're going to pay out on. All right, 29. Investment. Investment calls with a hot stock tip. He believes that if the economy remains strong, the investment will result in a profit of $50,000. If it's moderate, it'll result in a profit of $10,000. If it goes recession, it's a loss. Okay. You contact the accountant who believes there's 20% chances for each of these. What is the expected profit from the investment? So if X is the profit, then we want to make a probability model, probability of X. Well, what are the profits? The profit could be 50,000, could be 10,000, or it could be a loss of 50,000. And what's the probability of each of these happening? Well, it could be 20%, could be 70%, could be 10%. Okay, so the expected profit is 50,000 times 20 plus 10,000 times 70 minus 50,000 times 10, right? Because you lost 50,000 10% of the time, but you make this the rest. And if you do that calculation, you get $12,000. So on average, or let's actually, in this case, instead of saying on average, we can say this. In the long run, in the long run, that means this exact investment is going to happen over and over again. So yeah, this type of investment, let's just say that, will yield $12,000 in profit. So sometimes you lose big, sometimes you win big, sometimes you win in the middle, but on average, it's going to be $12,000 if this happened over and over and over again. All right, let's do one more on this one, 31. Roulette. Game of roulette, player plays $5 bet on 17 and have a 1 in 38 chance of winning because there's 38 places on the wheel. If the metal ball lands on 17, they win $175. Otherwise, they take the $5. That's a nice profit, but it's not, you don't have a very good chance of it happening. What's the expected value of the game to this player? If you played the game 1,000 times, how much would you expect to lose? So let's make a model here. So X is the expected value of the game. Okay, so this is going to be the winnings. How much is this player going to win? Okay, well, they're either going to lose $5 or they're going to win $170, right? Because they win $175, but they paid $5 in to be able to make that. So let's think about this for a second. They paid the $5, you win $175. So you win $175 because they don't take your money to play. You just win the $175 on top of your $5. Okay, the chances that you lose or win is 1 in 38. The chances you lose are 37 out of 38. This is, of course, probability of X. Okay, remember, these are dollars. So the expected winnings is -5 times 37 over 38 plus 175 times 1 over 38. All right, so let's see what his expected winnings are going to be here. So to be 37 divided by 38 is, well, 0.97 times -5, and then plus 175 times 1 over 38, and I get -0.26 or -26 cents. So in the long run, okay, so in the long run, a player will lose 26 cents per game on average. Okay, now if they play 1,000 games, it's going to be $1,000 or 1,000 games times 26 cents, which is $260. Okay, so they're going to lose 26 cents per game, and they'll end up losing this. It's actually negative, so that'd be negative. So in those 1,000 games, are they going to win once or twice? Maybe, but they're going to lose the rest of the time, and so this will be the net loss. Okay, all right, and let's hold it right there and go to the next one.